exceptions are there. The trouble with the orthographic projection is that one view usually not enough. As I said that in this, if I want to draw orthographic projections of this drawing, if I have drawn the isometric drawing of this, means if I have drawn the 3D part of this, then I can have what is the height of the object, what is the length of the object, and what is the width of the object. But if I am looking it from the top only, then what I will have, I will only have length and the width, but I cannot judge the height if I am looking it from the top. How can I judge that what would be the height the object can be having? We can have the height from the front side. If we are looking it from the front, then we can say yes, this would be the height of the any sort of object. Let me give you one simple example. If you are flying in the plane and you see any tall building from the top, from the top side, if you are flying in the plane and you are seeing a building, you cannot judge that this building is 50-story building. If you want to judge how many floors are there in the building, you need to go down and you need to see it from the front side, and you need to count that yes, these are the 50-story building. So this is the basic problem with this orthographic projection. One view might not be enough for any object. Yeah, map as well as any building's floor plan can be a exceptions for the same. Orthographic projection can said as multi-view projection also. As you can see over here, the front view, it is the front view, we are seeing it from the front. Top view, if we are seeing it from the top. Bottom view, if we are seeing it from the bottom. Right hand side view, if we are seeing from the right hand side. Left view, if we are seeing it from the left side, and the back view, if we are seeing from the back side. So these kind of multi-view can be generated with use of the orthographic projections. That's why it is called multi-view projection also. One more thing, you must know that all this view will be in respect to each other. You need to draw top view in respect to front view only. You need to draw side view in respect to front view only. All view are associated with each other in well manner. It draws object as it would be seen from the several different locations. These views are flat view with all angles shown exactly correctly and all measurements to the scale. Now, what if we want to compare the projections? In the bottom portion, you are seeing the orthographic multi-view projection. On top of it, you are seeing oblique projection. Perspective drawing look nice when used by artists, but isometric, oblique and multi-view projection give more accurate information when used for the technical drawing. I already said that if you want to give a presentation to a non-technical guy, then you might use the perspective drawing. He just want to look how my final product will look like. But if in terms of we are talking about the technicalities, then we must have also isometric, orthographic or oblique drawing, which will give us proper and accurate information about all the technicalities. Isometric drawings show accurate dimension but some distorted angles. Oblique drawing give accurate dimension but for the one side only, whereas orthographic projections are the best choice for most technical drawing. If you want to describe any technical drawing, then orthographic projection can be the major parameter. Comparing about the perspective and isometric, you can see that over here vanishing point has been given. Because of this, the lines are converging and we cannot see the perfect height of the object. Over here in isometric, you can see the clear 90-degree line with each other. Now let's say comparison of the projections in terms of orthographic projections. Top view can be used for drafting, maps and floor plan. Orthographic multi-view means with the more than 2 views, technical drawing, drafting and conceptual sketch. Sometimes true perspective with 1, 2 or 3 vanishing point. This kind of drawing can be artistic drawing or the conceptual sketch. If you are just conceptualizing your design, then this kind of perspective can be perfect. Isometric, it are simulated perspective views. They can be used for conceptual sketch as well as technical drawings. Oblique, it is also part of simulated perspective drawing. It is used for the conceptual sketches. How isometric projection look like? If you see that a rectangle 3 by 6 square with the single square on the upper right corner. Over here the orthographic projections of the same have been judgmented. You are looking from the top. You are looking from the top on the yellow surface. Then how it will look like in the orthographic projection? It looks like this. This top portion, this square, yellow square will be in the upper right corner. This circle would be here and the whole rectangle. Now if you are looking it from the front, in isometric drawing you need to consider first of all that from which side you are seeing any sort of drawing. Over here we have considered this green portion as front side. Some of you might be using the this pink side as front side, but for the example let's consider this green side as front side. This front rectangle will be seen very easily. This portion, the height of this square can be seen from the front side. We have represented it over here, but here is the catch. In the orthographic projections we have all the technical details. That's why hidden lines are very much important to represent. If you are seeing any sort of hole, then you must implement the hidden line in the various views. Now if you look over here in the figure, this hole is there in this plate. We need to represent, but if you are looking it from the front side, it is not clearly visible, but it is hidden somewhere. That's why we have drawn with this like this. As you can see, hidden line, the dashed line. We have seen the line types in the previous part of the lecture. So these are the dashed lines. Over here, if you are looking from the right side, over here you can see that this portion would be clearly visible. So we have implemented this drawing. In the right side also we cannot see this circle, but we need to implement using the hidden line to show that there is a hole over here. So it is a clear understanding for the isometric to orthographic projections. Now, what is the scale? Scale is the relationship between the measurement of the object drawn on a sheet of paper and the measurement of the actual object. Oftenly, technical drawings are made with the different size from the object they represent. Scale reduction when drawing smaller than the actual object. Scale increase when the drawing is larger than the actual object. Dimensioning. When a drawing is done to scale, you should label it with the dimension. Use dimension line to label each dimension with extensions where necessary. You should also label enough edges to show all the dimension, but you do not need to repeat. If you see over here, if sometimes you see that these I need to draw the drawing of this marker, then if you have intimated this dimension over here like this, let's say this dimension is 50 mm, so you don't need to repeat on the another hand. If you have implemented for the one end only, then it is very much okay. You don't need to repeat the dimension by this side also. Just give dimension only for one time only. In Canada, dimensions are usually given in the mm. If you use different unit, then you need to write the unit. If you do not need to write, if you are drawing in mm, but it is necessary that you write your all dimensions are in millimeters. How we can show angle in degree? The angle of the degree can be denoted by the superscripted round on the upper side. Diameter can be shown as phi and the radius can be denoted by capital R. This is a basic example of the dimensioning. This is a multi-view projection, as you might already understood that this is top view, front view and the side view. Now, if you look at the front view, what you will find in the front view? You will find a height of the truck. This is a toy truck. Height of the truck, you will find the radius of the wheel you will find and the angle of the glass you will find. We have denoted the dimension as 100 over here like this. We have denoted dimension of diameter 40 over here like this. Now, we do not need to write 300 mm on each dimension. 300 means 300 mm unless any other unit is specified. This phi means that it is a diameter. If stated R, then it might be radius. This is how you can label any angle. To label any angle, you can use this kind of sign. In the side view, you can see the width of the toy truck tire as well as the height of the cabin. In the top view, you can see the total length of the truck, total width of the cabin as well as total width of the trailer. To label the small dimension, this dimension will come inside and the arrow would be generated outside of the drawing. This would be isometric drawing for the toy truck. If you want to denote dimension in the isometric drawing, then you can denote like this. Parallel to the line, 100 mm cabin length, 100 mm trailer height, 60 mm width and 300 mm length. Sometime you need to write the instruction, then you can use the leader and write the instruction that this glass would be clear plastic glass. Dimension can also be shown in the isometric drawing, but you need to be careful that you need to show only important dimension only in isometric drawing. You don't need to indicate all the dimensions, but you need to implement the necessary dimensions only. Now there are some sort of diagrams. Diagrams are simplified versions of the drawing. Diagram shows that how object work, but they necessarily not look like how they look. Diagrams often use abstract symbols rather than actual pictures to represent the things. Let's say this is a circuit diagram. It doesn't show that how circuit looks like, but it tells that how electrician connects all the things like this. The denotations will be given to various objects. Basically these kind of things are very much necessary if you are drawing all the drawing for your electrical engineering or for the electronics engineer. You must draw the drawing, but it also indicates the technical details, but it does not look like the actual thing. If you say that over here a resistor diagram have been shown, resistor symbol have been shown, but the resistor do not look like this. It is the symbol for the same, but it indicates all the technical details that it is R7 and it is 470 ohm resistor. Over here speaker have been symbolized, but it indicates the technical detail that it is 8 ohm 1 watt speaker. It is a transformer, T3 SL 100 byte transformer. This is ground and the input watt would be 6 watt. So a circuit diagram can be like this. So basically any sort of diagram can be technical drawing, but it do not look like the same which will you see in the physicality. Diagram of the energy conversion unit. For the mechanical engineers, there will be some sort of block diagrams in your next part of your semesters. You will need to draw the particular block diagram for your power plants, for your energy conversions, how all the energy conversions from the one form to another, how a air compressor work, how a engine work.